And welcome back, and we're on to the 11th of Feb, further maths 5 a day, and let's look at this first question, which appears to be a circle theorems question. So what am I going to do? Okay, this is the one that's designed, catch you out is probably not the right way of saying it, but it's checking you've seen the theorem, because the circle theorem you're thinking of, if I draw a quick diagram, it's probably easy to show you. So let's draw the diagram here, and let's draw what we've got. So we've got this here, there's my center, and there's my attempt to draw in the same diagram. The point is, this angle here is going to be twice this angle here, not the angle inside. So a really common error. So there's a few ways I can do this. So I can actually go back to working out the reflex angle at O, or I could work out the opposite angle using cyclic quadrilaterals. Let's do that, we might as well. So I'm going to call this angle here angle A. I'm going to do it slightly differently to how some of you may do it. So angle A using cyclic quadrilaterals is going to be 180 minus x minus 30, which is 150 minus x. Then angle this one here, so 2x minus 40, well, now I can use my circle theorems rule. So it is therefore the case that 2x minus 40 is double the angle at the circumference, so 2 times 150 minus x, which means that 2x minus 40 is equal to 300 minus 2x. Add 2x to both sides, it's going to give me 4x. Add 40 to both sides is 340, and so that means that x equals 340 over 4, which is going to be, well, 34 over 4 is 8, and 20, which is 5, which is going to be 85 degrees. Nice question, and quite an easy one to get wrong as well, so I'm glad that question appeared. Next question. Oh, we have another simultaneous equation. We had one of these a couple of days ago, didn't we? Now, a couple of days ago, I missed the fact that there was a ratio between the x and the z, which meant I could have got to one of them quicker. So have a quick look at what I've got. I've got 1, 2, I'm reading the coefficients of x, y, and z. So I've got 1, 2, and 4, 7, 4, and 6, 3, 1, and minus 1 and 2. So there isn't an obvious pattern here to do. So in this case, I'm going to go back to just trying to eliminate one of the variables. And again, actually, I'm going to do the z, because z's are 4z, 6z, and 2z, and that's sort of a nice little factor, isn't it? So let's label them up again. So 1, 2, and 3. And I'm going to start by doing equation 1, which is x plus 2y minus 4z equals minus 13. And then I'm going to do equation 3, and I'm going to multiply that by 2. So 2 times equation 3 is going to give me 6x minus 2y plus 4z equals 20. Now, remember when I said there isn't a pattern? Actually, there isn't. It's clearly the y and the z are double the y and z in the first equation. So actually, this is going to work out quite easily again, isn't it? So let's, what am I doing? I'm adding the equations. So if I add the equation, I get 7x is equal to, well, 2y minus 2y goes away, 4z minus 4z goes away, and 20 minus 13 is 7. Even these numbers are straightforward, which means x is going to be equal to 1. This is turning out to be a bit easier than I thought. Okay, right, what do we then have? So I've done equation 1 and equation 3, so I need to use equation 2 now. So let's do the same thing again, and I'm going to multiply, I'm going to write out equation 2, which is going to give me 7x plus 4y plus 6z is equal to 14. And then I'm going to take, well, I'm looking at the z's again. So 6z and 2z, so I'm going to multiply equation 3 by 3, which is going to give me 9x minus 3y plus 3 times 2 is 6. 6z is equal to 3 times 10, which is 30. Now this time I need to take away, don't I? Now I'm going to do the bottom minus the top, because the numbers look slightly better. So that's going to give me 2x, where I know x is 1, minus 3y minus 4y is minus 7y, is equal to 30 minus 14, which is 16. And I know x is 2, so therefore minus 7y equals 16 minus 2 times 1. So x is 1, so 2 times 1 is 2 is what I meant to say, which is equal to, well, 16 minus 2 is 14. So therefore minus 7y equals 14, which means that y is equal to minus 2. Thankfully the numbers aren't too bad, are they? Now let's go back to equation 1 and fill all that in. So x is 1, plus 2 times minus 2, because y is minus 2, minus 4 times z that I don't know is minus 13. So minus 4z, well 1 minus 2 times 2 is 1 minus 4, which is minus 3. Let's write this here actually. So minus 3 minus 4z equals minus 13. Let's add 3 to both sides, so equals minus 10, which means that z equals 10 over 4, which is 5 over 2, or 2.5. Oh, those quite nice numbers until that stage. So therefore x equals 1, y equals minus 2, and z is equal to 5 over 2. Not terrible. And actually, even though I didn't spot it, the z's and the y's cancel out quite early on, just to make a fairly easy x fall out. Makes the whole calculation slightly easier. Next one. Last question today. The curve C has equation, gives you an equation. Now I'm guessing without reading the next line, I'm going to differentiate, but let's carry on. Work out the coordinates of any stationary point. Yep, so that's your differentiation trigger on this curve. Oh, and determine their nature. Right, so if you do GCSE, you don't need to do the determine their nature. If you do further maths GCSE, you need to both differentiate and determine their nature. So in other words, I need to find out the turning points first. So let's differentiate. So dy dx is equal to minus 3x squared plus 12 times 2 is 24, x minus 36. And I need that to be 0, because I'm trying to find a stationary point. So I'm trying to find where the gradient's 0. So I'm going to divide by minus 3. So I'm going to do both the 3 and the minus at the same time. So it's going to be x squared minus 8x plus 12 is equal to 0, which I can factorize to, 6 and 2, of course, which is x minus 6, x minus 2 is equal to 0. So in other words, my stationary points occur when x equals 2 or x equals 6. Now, the annoying thing is I need to go back and put these into the y equation to find out what the y value is. So let's do that here. So therefore, y, if x equals 2, is, well, 2 cubed is 8, so it's minus 8. 2 squared is 4. Just to be clear, I'm putting it back into this equation here. So 2 squared is 4 times 12 is plus 48. And minus 36 times 2 is minus 72. And all that gives me, a calculator out so I don't mess this up, is minus 8 plus 48 minus 72 is minus 32. Whew. Okay, not easy numbers. Right, now I'm going to put the x equals 6 into this equation again. So again, into this top equation. So this is going to be a little bit harder. So I might do this to my calculator so I don't, again, get it wrong. So 6 cubed is 216. So that's minus 216. Plus 12 times 36. So 12 times 36 is 432. Wow. And then minus 36 times 6, which is 216, of course it is, minus 216. So I've got 432 minus 216 minus 216, which is 0. Of course it is. Yeah, because 216 times 2 is 436. Yeah, obviously. That's why calculators are dangerous, because you miss the obvious things. Anyway, coordinates of my stationary points are 2 minus 32 and 6, 0. So far, so good. Right, next part of this question, I need to determine their nature. So what I now need is I need d2y dx squared. In other words, I need to differentiate the thing I differentiated earlier. So I'm differentiating this equation here. So minus 3 times 2 is minus 6x, and 24x becomes 24, and minus 36 goes away. And then what I want to do is I want to do d2y dx squared. What am I writing in there? Dx squared. Sorry, long night. Dx squared. And I want to work out that at the point 2. So x equals 2. So x equals 2. And that's going to be minus 6 times 2 plus 24, which is, well, minus 12 plus 24 is 12, which is greater than 0. So therefore, it is a minimum. I'm guessing the one's the maximum because it's a cubit, but let's carry on anyway. So therefore, d2y dx squared at the point x equals 6 is going to be minus 6 times 6 plus 24, which is, well, minus 6 times 6 is minus 36, plus 24 is minus 12, which is less than 0, so therefore it is a maximum. Now, even though the job of the examiner is to sort of go through your work and check you've written the right things and you've got it right in the right place, let's just make this really clear. So I will just write at the end, I've got 2 minus 32, which is a minimum. And I've got 6, 0, which is a maximum. And not that you have to do this, but as a quick aside, this is a negative cubic, so it does this. So it must be the case that the smaller number, the 2, must be the minimum, and it must be the case that the 6 must be the maximum. So that makes sense anyway, but that wouldn't be a proof, but it just helps you think about what's going on. And that is it. Question done. As ever, decent mix of questions today. We haven't had circle theorems in a while. I'm a bit sick of these simultaneous equations, so hopefully we won't see one of those for a few days. And a nice little differentiation question with some reasoning at the end, which we don't often get. As ever, like, subscribe, and I'll see you for tomorrow. Thanks all.